A chatbot gives you an answer. An AI agent can take action. That difference sounds small until you follow the chain. The agent might search your files, edit code, call an API, open a browser, use credentials, route a task to another agent, summarize what happened, and ask for approval only at the end. Now the safety question is no longer just, did the model say something bad? It becomes, who authorized this sequence of actions? Who could see what happened? Who had the ability to stop it? And if something goes wrong, who is responsible? This is why regulating agent-based AI is harder than regulating chatbots. The risk has moved from speech to delegated action. A recent paper called Regulating Autonomous and Agentic AI makes a useful point. Many regulatory systems assume that the regulated party has knowledge and control over the relevant process. That assumption is comfortable when a company builds a normal workflow. Employees follow procedures. Managers can supervise. Auditors can inspect records. If something fails, you can usually identify who made the decision or who owned the process. Agent-based AI weakens that model. A deployed agent is not just a model. It is a model provider, a tool layer, memory, prompts, orchestration logic, browser sessions, API credentials, third-party services, and sometimes other agents. Some knowledge and control live with the deployer. Some live with the model provider. Some live in the harness. Some live in tools the operator barely understands. So, accountability gets blurry. The user may have provided the goal, but not the individual steps. The deployer may have configured the agent, but not predicted the exact path. The model provider may have trained the base behavior, but not chosen the customer's tools. The tool provider may have exposed powerful actions, but not controlled the agent's intent. That is the core governance problem. The action is real, but responsibility is distributed across a supply chain. One mistake is to treat AI agent as a yes or no category. A better frame is an autonomy ladder. At the bottom, the system suggests. It gives advice, but a human acts. One step up, it drafts. It writes the email, the code patch, or the report, but the human reviews before anything leaves the sandbox. Then it acts with approval. It can prepare an action, but a person must click the final gate. Then it acts inside bounded policy. Maybe it can merge low-risk changes, reorder inventory, or triage tickets, but only under explicit limits. Then it delegates. It can spawn subagents, ask specialist models, or route tasks through a multi-agent workflow. At the top, it pursues goals across systems over time. It has memory, credentials, a budget, and a mandate that persists beyond one prompt. Those are not the same regulatory problem. The important variables are practical. What external authority does the system have? Are actions reversible? How long can it operate? Can it affect third parties? Can it spend money? Can it access private data? Can it delegate to components the user never directly approved? Regulation that ignores those differences will either be too weak, where agents actually act, or too broad, where systems merely assist. The phrase human in the loop gets used like a magic safety spell. But the real question is, where is the human in the loop? A human can approve the goal before the agent starts. A human can supervise each tool call. A human can handle exceptions. A human can review the final result. Or a human can be legally accountable after the fact, while having no practical ability to control the system during execution. Those are very different. The paper The Boundaries of Automation argues that human participation may persist even with highly capable AI. Not just because models are imperfect, but because humans sometimes provide complementary judgment. Because participation itself can be valuable for learning and agency, and because in some activities the target is not fully defined in advance. The goal emerges through the human-AI interaction. That matters for agents. If a student uses an AI tutor, the point may not be only to produce the answer, the point may be to learn. If a doctor uses a clinical assistant, the point may not be only to generate a recommendation. The point includes responsibility, judgment, and patient trust. If a developer uses a coding agent, the point may not be only to produce a diff. The point includes understanding what changed and why. So human participation is not just a final checkbox. It has to be placed where it preserves meaningful control. A useful governance point is that agents do not only fail by refusing, hallucinating, or saying something offensive. They can fail by doing too much. The AI Assistance Overassist paper studies intervention behavior in learning settings. The basic problem is simple. Help is not always helpful. If an assistant intervenes too early or too often, it may reduce the user's own reasoning and cognitive engagement. That is an agent-based failure mode. The system is not necessarily malicious. It may be trying to help, but its intervention policy is wrong. This generalizes beyond tutoring. A coding agent can edit before it understands the bug. A research agent can summarize before checking provenance. A workflow agent can optimize for speed while hiding uncertainty. A personal assistant can take initiative in a context where the user wanted reflection, not automation. So governance needs to cover when the agent should act, not just whether the action is allowed. The control surface is timing, confidence, reversibility, and user intent. Multi-agent systems add another complication. Context can be transformed as it moves through the system. One paper on direct exposure versus multi-agent mediation reports a striking behavior. A model appeared safer when it saw a dangerous objective directly than when other agents transformed and relayed the direction. In the mediated setup, the downstream user-facing component did not see the raw objective, its manipulative clauses, or its source. I would not treat one paper as the final word on multi-agent safety. But the design lesson is important. A final output is not enough. If an agent acts after a chain of planners, critics, reviewers, routers, and subagents, you need the trace. You need to know what the original goal was, how it was transformed, which components saw which context, which tools were called, and where constraints were added or removed. Otherwise, the final visible message can look safe, while the workflow served a different objective upstream. This is where agent governance starts to look like infrastructure. You need logs, provenance, policy checks, and replayable traces. Not because paperwork is fun, but because without them, nobody can reconstruct what actually happened. So what would a practical governance stack for agent-based AI include? First, declared permissions. The agent should have an explicit manifest of what it can read, write, call, spend, and delegate. Second, scoped credentials. An agent should not receive a master key when it only needs a narrow token. Third, sandboxing. File edits, code execution, browser sessions, and tool calls should happen in bounded environments with clear promotion steps. Fourth, approval gates. Irreversible or high-impact actions need human approval before execution, not only after logging. Fifth, action budgets. Time, money, API calls, emails, commits, and external requests should have limits. Sixth, trace logs. The system should record goals, plans, tool calls, subagent delegation, approvals, and final actions in a way a human can actually review. Seventh, evals for overreach. Not just does the agent succeed, but does it act too early, hide uncertainty, escalate authority, or bypass the user's intent? Eighth, incident reporting and rollback. If an agent makes a bad change, the system needs a path back. Notice what this sounds like. Not just a model policy, it sounds like a control plane. The same harness layer that routes agents, sandboxes, workspaces, tracks cost, and records outputs is also where governance becomes enforceable. This is the shift. The model matters, But for agent-based AI, the model is not the whole system. The real object of governance is the delegated-action system. Model, tools, memory, policies, credentials, logs, human control points, and the organizations that assemble them. That is why regulating agents is harder than regulating chatbots. A chatbot can be judged mostly by what it says. An agent has to be judged by what it is allowed to do, what it actually did, who could stop it, and who owns the consequences. If the industry gets this wrong, we will end up with fake control, humans nominally in the loop, logs nobody reads, and responsibility assigned to the person least able to understand the chain. If we get it right, agent-based AI can be powerful without being unaccountable. The future question is not just whether an AI system is safe, it is whether the action system around it makes responsibility real.